The thyroid gland, it actually has two lobes, the right and the left lobe, and it's connected by this small structure here called the isthmus. I don't like that word. It's located anterior to the trachea, which is that blue tube you can see right there, and inferior to the larynx, right? And this huge structure up here is the larynx. The edges of the thyroid, it like curves around the larynx, and there's a pretty good amount of mass posterior to the larynx. Many people forget that the thyroid gland generates two hormones, a hormone called the thyroid hormone, which actually is two hormones together, T3 and T4. And it also makes a hormone called calcitonin, which has nothing to do with the thyroid hormone. Calcitonin is strictly involved in regulating calcium in the body, and it's discussed in another mini lecture. Thyroid histology it's quite distinctive. Just Google thyroid histology and you'd be like, wow, there are similarities in these pictures. The gland is made up of large circular structures called follicles, right? Kind of like it reminds you of hair follicle, but what a follicle is that it's got this clear substance on the inside of it called colloid. And the colloid stores thyroglobulin, which is a precursor to T3 and T4. The follicles are surrounded by all of these cuboidal cells that you see right here with their nuclei characteristically in the center of them, right? And these cells, these are called follicular cells. And what these epithelial follicular cells do is they secrete the thyroid hormone. The colloid stores the thyroid hormone or the precursor to it. You have this massive amount of storage in the colloid because you never, ever, ever want to be without the thyroid hormone. Speak to someone who has hypothyroidism, and they will tell you how horrible it is to need more thyroid hormone but not be able to like make it at a rate that is quick enough. So this is why it's really important that you store excess hormone. Unique to the thyroid gland is the storage of this excess hormone. And this storehouse of the thyroid hormone, it can be mobilized when and if your follicular cells ever stop making thyroid hormone. Actually, if you gain weight, you may add follicular cells so that you can make more thyroid hormone for the added cells in your body. Between the follicular cells and not touching the colloid are these cells here that are called C cells, and these are the ones that secrete calcitonin, which has nothing to do with the thyroid hormone. These cells just happen to be here in the thyroid organ, right? Whoever was making the thyroid organ was like, I don't know where to put these cells. And it was like, just put them here. It's kind of like on a matching, right? Where you're like, I don't know where A goes or B. I'll just put A in both of them. The thyroid hormone itself, the hormone that this organ right here secretes, because there's a number of thyroid hormones, right? But the one that's secreted by the thyroid organ on your neck consists of two molecules, T3 thyroxine and T4, which is tetraiodithyroxine. T3 and T4 can be measured in your blood. And in fact, we can measure the amount of T3 and the amount of T4. Thyroid hormone, it acts with these two molecules working together. And thyroid hormone acts as a non-polar molecule despite the fact that it is polar. Strange. And so it binds to a protein called the thyroid binding globulin while it's in the bloodstream, right? And this is because we know that molecules that are non-polar need to bind to some part of some type of protein to circulate in the blood. There are actually a few other transporters. Thyretin and albumin can actually transport the thyroid hormone as well. But just remember, with such a really important hormone, you would want that there are a few different carriers for it, right? So that you're not dependent upon just one carrier. The thyroid hormone is removed from circulation by the kidneys, which is different from some of the hormones we've talked about that are removed by the liver. There is a small range for the thyroid hormone in your blood, right? Very small. It doesn't have a big wide range like some of the other hormones. It doesn't fluctuate. It's not supposed to. The release of thyroid hormone from the colloid and the removal from it by the kidney need to be closely matched to maintain that short range of equilibrium. Thyroid hormone affects nearly all cells in the body, right? All cells that have nuclei and or mitochondria, because by targeting those two organelles, I can increase the ATP production. This is a really general statement that you'll hear. The thyroid hormone raises metabolism. What does that mean? Ultimately, what it means is that the thyroid hormone causes your cells to make more ATP by increasing reactions in both mitochondria and your nucleus. The thyroid hormone increases ATP production, but when it does that, it also raises your demand for glucose and oxygen. So, a patient with hyperthyroidism may have a high respiratory rate to keep up with the oxygen that's needed for that increased metabolism. Your hypothalamus can increase your feelings of hunger, right, to increase your input of glucose. So you can also, if you don't pay attention to those hunger pangs, you can start to harvest energy from your adipose deposits, right? Because both hunger and harvesting the triglyceride from adipose deposits would give your mitochondria glucose to make more ATP. Thyroid hormone also exhibits something called a permissive effect or permissiveness. And what this does is that the thyroid hormone only in excess amounts. When it's in excess amounts, what it does is it puts extra receptors into cardiac muscle for epinephrine. And so thyroid hormone, it doesn't increase the amount of epinephrine that you're making. What it does is it increases your susceptibility. I'm sorry, let me make that more clear. It increases your heart's susceptibility to the epinephrine that you already make. And so this can account for the sign of the increased heart rate that is many times associated with hyperthyroidism. The hypothalamus monitors blood levels of thyroid hormone and it releases the thyroid releasing hormone into that hypophyseal portal system. Right? And the thyroid releasing hormone travels directly to the anterior pituitary gland. And TRH, like all releasing and inhibiting hormones, it only exists in that hypophyseal portal system in the infundibulum. And TRH and any releasing hormone can never be measured in your blood. So if you have a thyroid issue, I can't ever tell what your TRH is really doing. I can only make an assumption. There are cells, though, in the APG called thyrotrophs that are affected by TRH. These are the cells that have receptors that receive the TRH hormone. And when they do, these thyrotrophs, they release TSH, the thyroid stimulating hormone, into systemic circulation. TSH circulates all throughout the body until it hits the thyroid organ, right? And it's the thyroid organ that it targets, and it specifically TSH specifically targets the colloid to release TH, and then it targets the follicular cells to make more TH to replace the TH that was released. this hormonal cascade here, right? This hormonal cascade, it exemplifies a negative feedback loop where both the hypothalamus and, right, both of these are monitoring the level of TH in the blood, and both of these organs can further inhibit or further encourage the production. Thyroid hormone, as we mentioned, its effectors are anything with a nucleus or with a mitochondria. So I just want to point out here, right? You've got three hormones. It is very easy to become confused. I encourage you to make a drawing of this slide or this convoluted negative feedback loop that I have. Make your own drawing. So we can have hypothyroidism or hyperthyroidism. And these diseases, each one of them, they have many causes, each one of them. The most common cause of hyperthyroidism is Graves' disease. In this disease, there are autoimmune antibodies that have the same shape as TSH. And the autoimmune antibodies are made by some like rogue malfunctioning cell in your bone marrow. These antibodies, they circulate and they attach to the receptors on the follicular cells in the thyroid gland. And even if thyroid hormone levels are high in the blood, it doesn't matter. These antibodies, they don't care. They cause the thyroid gland to continue to release the thyroid hormone. Because the thyroid hormone in the blood is high, the hypothalamus is like, well, I'm not needed, right? You obviously don't need me. So it shuts down production of TRH. The anterior pituitary gland, it does the same thing. It shuts down production of TSH. I can measure the high TH in your blood. I can measure the low TSH in your blood. I cannot measure the TRH because it's only secreted into that hypophyseal portal system. On the other hand, a goiter is an example of what happens with hypothyroidism. An endemic goiter is a form of hypothyroidism that results from a diet low in iodine. The thyroid hormone is made from iodine, and it's the only substance in your body that is made from iodine. If iodine is not obtained in your diet, you cannot make thyroid hormone. So your thyroid hormone is low in your blood, and your hypothalamus senses this. And it starts screaming at the anterior pituitary gland. It's like, yo, did you know thyroid hormone is low? Release your thyroid stimulating hormone. And so the APG, it releases its thyroid stimulating hormone. It connects with the thyroid or gland, but nothing happens. Because the thyroid gland is like, I don't care how much you scream at me. I can't make the thyroid hormone. There's just no iodine available for me to do that. But the APG and the hypothalamus, they just keep screaming at the thyroid gland. And you have to remember that TSH, it not only encourages the follicular cells of the thyroid gland to release the thyroid hormone, TSH can also cause growth of those follicles and add more follicular cells in an attempt to make more thyroid hormone. So the thyroid gland is like, hey, all right, so if I add more follicular cells, maybe the anterior pituitary gland will stop screaming at me. No, it doesn't though. The thyroid gland, it adds more of these follicular cells, but it doesn't satisfy the need of making more thyroid hormone because we're not getting that iodine in the diet. So it's the addition of these excess follicular cells that produce a goiter. I just want to note that there are more diseases than an endemic goiter that make hypothyroidism. There are more diseases than Graves' disease that make hyperthyroidism. These are just two mechanisms of how that can happen. Treatment for hypothyroidism involves thyroid hormone replacement therapy. I believe the drug is called Synthroid, which is a synthetic version of thyroid hormone. I've heard some people say that Synthroid has a lot of side effects for them or doesn't work, and I've heard some people say that the natural version of the drug is a little bit better for them. Um, you know, sometimes insurance I've also heard doesn't cover it, but just adding this drug, it doesn't cure your hypothyroidism in a pinch. It can take months to years for these three organs, the hypothalamus, anterior pituitary gland, and your thyroid gland. It can take years for them to like start to figure out how to work with each other again. Hyperthyroidism treatments are all dependent upon one theory: remove the excess follicular cells, and thyroid hormone production will decrease. It's true. I mean, in theory, that is true. So, surgery can immediately remove excess follicular cells. The use of radioactive iodine can also kill follicular cells. Yes, yes, we intentionally give you radioactive iodine. And you can't hold babies, you can't be near small children or near your pets for 72 hours after you are radioactive. I have radioactive PET scans, and I am not supposed to pet my cats for 24 hours afterwards. But of course, when I come home from the PET scan, they're like both on top of me. They're like, we want your love and your radioactivity. All right, so I'm sorry, I digress. Radioactive substances are usually bad because they kill cells. But in this case, because it's radioactive iodine, it's only taken up by your thyroid cells, and therefore it can only kill your follicular cells, reducing the excess amount of follicular cells. I can have this radioactive iodine float around your body, and it will only kill the follicular cells. Now, with both of these things, surgery and radioactive iodine, there's no like perfect amount. I don't know exactly how much to take. I don't know exactly how much to give you. I mean, there are ranges preset, but it's an estimate of the cells that we would like to remove. And just like with hypothyroidism, it can take months to years for your three organs to again figure out how to work with each other.